Hey guys, so I'm showing you here the Nucleus-Hermès real-time, so the real-time version. The system comes with the headset, equipped with the POV camera, and with a banana bag that contains a Raspberry Pi. So the whole thing is untethered. I can walk around with it. This solution is meant for biofeedback hacking, mostly for biofeedback hacking. It's a system that will process emotional and cognitive metrics in real time. It has online calibration. It's really a standalone system, so you can record data for playback later. Let me just show you like a quick demo of how what's available and how it works. So first of all, you have the POV camera here. So this website here that you see. This website that you see here is hosted by the device, so you can connect Hermès 9. So this is Unit 9, Hermès 9 local, so it's on the local network port. I have some status element. I have camera preview. There's a little bit of a delay between the camera and what we see. It's kind of like a queue. What's nice is when you detect a reaction, you can look at the camera and it's pretty much aligned. Notice it's kind of like the same delay between both. So you have the camera preview here. It's good enough. I mean, it's not a high quality camera. You can control the quality, but the idea here is that it gives you an idea of what's going on in the environment. So you can use LLM to do contextual interpretation. So that's really a cool feature of this system. Then you have like the metrics here. You see there's a bunch of metrics, emotional metrics. Emotional metrics are by design are already calibrated between 0 and 1. The sum of all metrics is equal to 1. Kinds of metrics are you have access to the raw metric and also the calibrated metric. So the benefit here of the calibrated metric is that it's an online calibration. So you don't need to worry about like individual variance. I mean, the whole thing gets calibrated. It takes a few seconds to get there. I think it takes about 30 seconds to kind of gather some data, but it's a dynamic range that gets updated based on the metric. So it kind of like really captures the variations of the metric. So you have engagement, for instance, so I'll make it go up. No, engagement is one of the most reliable metric. So only like being really concentrated on, I just look at the point and I just like focus my attention on it. So you have engagement and focus are very similar. Motivation, relaxation, workload, a little bit less reliable when you work with them, but those are like kind of canonical metrics coming from EEG literature. So all of these metrics are based on EEG. I'm also working on this index here. It's kind of like experimental right now, but the freelance index is kind of like the idea of like agency. Anyway. That's something different. Now the emotional metrics. I mean, at React, we have like an expertise in emotional metrics. Of course, it's based on muscle activity, facial muscle activity. If I talk and everything, of course, there's some jitter in the data, but let's go one at a time. So if I just stay still, you see I have the neutral expressions. Now I'll trigger a contempt here. So that's a small asymmetric smile, big smile, happiness, anger is easy to trigger as well. This is a very common, so contempt in the literature, they call it contempt. In practice, it's more of a small corner smile, asymmetric smile that can be small happiness or could be slightly like negative. So it's really context that helps you interpret it. Anger is the most common. Anger will show up as frustration, friction. Mental workload will trigger anger as well. Happiness is really like big smiles. And the other ones that we have surprise. Okay, surprise tends to be mixed up a little bit with fear and sadness. So these three metrics are a little bit harder to classify. So this is why they tend to be mixed up a little bit. We're updating the model, but you can kind of like use the context here to tell. Sadness is very rare in nature. I mean, it takes like quite a context to really induce some level of sadness. Fear can be a quick reaction, and then otherwise, I think the three kind of like based on context. If it's positive, I'll call it surprise. If it's negative, I'll call it anxiety. And basically, this is what we have here. That is, you see, there's an anxiety metric here. It's kind of like a composite metric that sums up sadness and fear. So it kind of like creates this this usable metric that you can just like assume that is kind of like a negative, stressful reactions. The device can record data, so I can just press the button here. Okay, you see now the light is flashing, so this is recording data. This is amazing, so it keeps on streaming, but if I want to record a session to be able to do some playback, it records everything, e.g. raw data. It records the frames. The frame is basically the data that we see here extracted from this, the video. So this website here is hosted by the device, so I just connect remotely to the device. I can also, you see this is actually running on my PC, so it's a web page on my PC connecting to the video stream sent by the device, so it shows that anywhere on the network I can access the POV. And then I also have this one here, so those are the metrics sent over OSC. It's sent over OSC here, it's kind of like rebuilt or reframed into like this data structure here, so it's kind of like makes it more convenient. And the same data can be streamed over MQTT. The benefit of MQTT is that you also have like the control channel there, so you can control, you can send tags, you can start and stop recording through MQTT. The thing with MQTT is you need a broker, you need to configure it, but besides that, so OST is the simplest, MQTT is slightly more advanced, but gives you a little bit more options. And that's basically it. This is the kit. It's meant for advanced biohacking, so it's a solution that works out of the box. It's super convenient, and the software itself, the Raspberry Pi itself, is accessible. I don't publish the source code for the Visia software that runs on it, so the license is basically if you get the system, you can access the code, but you cannot distribute it. So that's kind of like the deal that I have here, because there's quite a little bit of IP. We have some models in there that we support. So it's kind of like the deal here. But it's a great system if you want to develop any type of like biohacking, affective computing, and that's the spirit here. So anyways, that's the end of the presentation. Thank you.